These notes are dealing with distributing and simplifying algebraic expressions. The first thing we're going to do is go over some key vocabulary that I will be mentioning and saying in every example that I do. So once you know the vocabulary, you'll understand the parts that I'm talking about. Most of these words, if not all of them, should be familiar to you from your past algebra and pre-algebra experience. The word coefficient refers to the number in front of a variable. And there are some different ways that this might look. So I'm going to give you a couple of examples so that you can see a variety of coefficients. In the term negative 6x, the negative 6 is the number in front of the variable. That is the coefficient. When we have x over 4, there is a coefficient here, but most people want to say it's the 4, and it's not. The 4 is a part of it, though. In front of the x, there's an invisible 1. 1's like to hide in algebra, so you have to put 1 there. And then this fraction, 1/4, becomes the coefficient. Right, so make sure that you recognize that division problems that look like this could also have a coefficient of a fraction. And then the other one that likes to sneak in on us is negative x. And if you notice, there's no visible number there, which means there's a 1 that's invisible. And when that invisible 1 gets put there, your coefficient becomes negative 1. So do watch out for those little ones that like to hide. The next word is variable, and a variable is simply a symbol that's mainly a letter used to represent a number. In algebra, it is all letters. However, in other levels of math, there may be different symbols that could constitute as a variable. Right? The word constant is an integer typically found at the end of an expression. And it has no variable attached to it. It's just a regular number. The word terms are your parts to an algebraic expression. And these terms are separated by a plus or minus sign. So that's how you know when you're getting to a new term. And we'll look at how to separate an expression and pick those out. In terms you have, or an expression you have like terms, and these are going to be your terms that are like each other. And the way that they are like each other has to be based on their variables and their exponents. So these are terms that are like each other. Including variables and exponents. And the last word is what we're really going to be doing with this, and that's simplifying. Every topic that we do with this page of notes is about simplifying these expressions. And that is when you combine all like terms and get rid of all parentheses. If you still have parentheses or if you have like terms still in your problem, you have not fully simplified, which means you are not done. All right, so now let's go ahead and take a look at some of the examples of things that you're going to have to be able to do pertaining to these words. The first thing you're going to have to do is name the terms, like terms, constants, and coefficients from an algebraic expression. So go ahead and take a moment and write down this long expression so that we can dissect it and pull out its pieces. First thing we want to do is identify the terms. Remember, terms are the items that are separated by a plus or minus sign. So as soon as you hit another plus or minus sign, you've separated a term. So this negative 6 is a term. Then this negative 3x is a term. You have positive 3y, positive 7, negative 4y, and positive 9. I mean, if I circle all of them, you can see that the sign in front of the number goes with the number that it's attached to. If you don't take that sign, you will affect your calculations and your simplifying later on in this set of notes and everything else later on too. right? Then we're going to go to, now that you've identified the terms, picking out the like terms, the ones that are like each other. And we have a couple different groups in this problem of like terms, right? Like terms have the same variables or they have no variables at all, and that's what makes them like each other. So if you look at this problem, we have positive 3y and negative 4y. Those two terms are like each other because they both have y's, right? But then there's another group. There's negative 6, positive 7, and positive 9. Those three numbers are all like each other because they do not have variables. There is nobody like the term negative 3x because there's nobody else with an x in it. So there's your two groups of like terms. The next thing we want to talk about are constants. Constants, remember, are the integers that have no variables attached to them. So if you just glance through your problem and look for all the numbers that have no variables, we have negative 6, positive 7, and positive 9. There are three constants in this problem. And the coefficients are your numbers attached to the variables. So find your letters and look at the numbers that are directly in front of them. Right? So we have an x in front of it's a negative 3, so that's a coefficient. We have a y in front of it's a positive 3, that's a coefficient. You have another y with a negative 4 in front, so that's a coefficient. The coefficients are just the number part, not the letters. Do not write the letters down. The letters are variables and they are their own separate piece. Right, now that we've pulled the algebraic terms apart and I've used the vocabulary that we need to, we're going to go in and start simplifying by combining like terms. And when we combine like terms, we're basically adding and subtracting only the terms that are like each other. So the only operation that's going on is adding and subtracting. So I'll start you off with a little bit of a basic one, and we'll see from there how much we can build up into this. Right, looking at the problem 10 minus 5x plus 3x, you'll notice that there are two terms that have x's. So those are your like terms, negative 5x and positive 3x. I like to circle my terms so that you know which ones are like terms, and that way you can see them very quickly. And then I use different shapes for other terms as well. So if we combine those like terms together first, negative 5 plus 3 makes negative 2. Keep the x behind it. The 10 that's in front has nobody to go with it, and it's a positive 10, so he just tags along in the back. There is a certain order to the way your answers have to be written. Your variable terms should be in front in alphabetical order, and your constants should always be in the back. It's kind of like a train. The constant is the caboose of the train, so it must always go in the rear. Right, if we take a look at another one that builds a little bit more into it, negative 6k minus 4j plus 6k minus 8. Notice I have more terms in this problem now, so it's a little longer, but the whole point of this is to simplify it and make it shorter. Always go alphabetical with your variables. So because j comes first, right, negative 4j doesn't have anybody else to go with, so bring it down into your answer. It's going to be the front. Right, then go to your k's, and if you look at them, you have a negative 6k and a positive 6k. Negative 6 plus 6 makes 0, so the k's go away. Do not write 0k. It is not okay to write 0k. Right, so you have to just completely cancel them out. They're gone. And then your constant is negative 8. Nobody goes with it, so he stays in the back. So there's your simplified answer on that one. Right, if we take 3p plus 4x minus 4p plus 8, again, stick with the alphabet first, and p comes before x, so we're going to take 3p and join it with minus 4p. 3 minus 4 is going to make negative 1p. You do not need to write the ones. If you do write them, I won't mark you wrong at this point, but down the road your teachers might do that for you. You need to realize that in algebra the ones are invisible. So this is negative 1p. Then comes the x, which nobody joins it, so just bring it straight down, positive 4x, and then nobody goes with the plus 8, so put the plus 8 in the back. There is absolutely nothing else you can do to simplify this problem because they're all different terms. And then the last one before we go to distributing has a lot of negatives in it, so please be careful of these negatives. That's usually what students tend to drop. All right, if you notice, you have the variable w, and there's three different terms of them. We're going to put all three of these terms together. Negative 9w minus 3w plus 2w. So go left to right. Negative 9 minus 3 is negative 12. Negative 12 plus 2 makes negative 10w. Okay, and then the minus 12 that's still left over is your constant. It goes in the back, and your problem is done. All right, but do go from left to right when you're combining more than one or more than two sets of the same variable. All right, the next thing we want to talk about is the distributive property. And look at some examples of that, and then we'll put the two together. It's not enough just to be able to do one by itself. For the distributive property, remember it's the number on the outside being multiplied to everything inside. So if we have 5 times w minus 8, okay, I like to draw arrows so you see exactly what I'm doing, right? But remember it's through multiplication. So 5 times w makes 5w. This is a negative 8. So when you go to do 5 times 8, it's really not 5 times 8, it's 5 times negative 8. And 5 times negative 8 makes a negative 40. Just because there's a subtraction sign in your parentheses does not automatically mean you're going to have a subtraction sign in your answer. So do watch out for your signs. Right? Sometimes the term that you are multiplying to everybody is in the back instead of the front. I'm not a big fan of this, but it's the way it shows up, so we need to be familiar with it. Whatever's on the outside, take it to everybody on the inside. And I always go to the front of the parentheses first. So 7 times y makes 7y. And then 7 times positive 19 is going to make positive 133. Okay. Okay. For other distributive problems, sometimes you have a variable on the outside. So if we have y times 12 minus x, okay, again, the y is going to go to everybody. So y times 12 is 12y. And your 12 is your coefficient, so put it in front of the letter. Do not put y12. There's no such thing. This is a negative x, and remember it's like a negative 1x if you need to write that 1 there. So y times negative 1x is going to give you negative xy. Again, remember that everything is alphabetical, so make sure that you write all your letters that way too. If you don't know the alphabet by now, you might want to learn it. For number 4, if you have a negative on the outside, parentheses, negative 3 plus y inside, right, be very careful with this. Remember that you have these invisible numbers that are going to be popping up and you can't see them. Right? So yes, there's a negative sign outside and there's parentheses, which tells you you're distributing. But what you got to realize is that there's a negative 1 hidden right here that is invisible that you can't see unless you force it to be there. Okay, so once you write it in, you can see what's going on. Negative 1 times negative 3 is positive 3. Then this is a positive y right here. So negative 1 times positive y is going to make negative y. Do not worry about your order with distributive problems, right, because they will work themselves out once we get through doing what we're going to do with them. Okay, and then the last example I need to show you under this property before we start merging it all together is a fraction on the outside. And I know everybody loves fractions, so let's see if we can make our way through this. Okay, again, you're still distributing that fraction to everybody. The numbers and fractions that I have picked are compatible to each other, so your fractions should go away if you're doing this correctly. Negative 2/3 times x is negative 2/3 x. Okay, now you can use your calculator to assist you, or you can use some computation and mental math that you know. First things first, this is negative 24, so negative times negative is going to create a positive. Okay, and then you have to ask yourself, how many times does 3 go into 24? Right, because 3 goes into 24 8 times. Change the number 24 to an 8, and now multiply 2 times 8, and you'll get 16. If you type in 2/3 times 24 in your calculator, it will also tell you 16. So just make sure you know some way through using that fraction. Don't panic because there's a fraction and just not do the problem. All right, and the last thing you have to be able to do, and this is where we want everybody to be for this class, is you have to be able to distribute and simplify in the same problem. In other words, it's going to have combining like terms and distributing in the same problem altogether. Okay, so it's going to look something like this. 6 parentheses y plus 8 parentheses minus 5y. Right? Anytime you have more than one type of simplifying to do in the problem, always distribute first. That's your number one thing to do. And it'll also stay number one in equations as well when we get to solving those next chapter. Right? So distributing happens first. 6 times y is 6y. 6 times positive 8 is positive 48. And then slide the minus 5y down. Now you can combine the like terms that you have. We have two terms that have a y in them. So 6y minus 5y turns into 1y. Again, you can put the 1 if you want to, or you can just leave it invisible like I have. Nobody goes with the 48, so it's just plus 48 in the back. So y plus 48 is your simplified answer from what you started with. If we take a look at another one, then I'll throw some geometry at you that involves this, and this is why algebra must come before geometry. All right, but let's take a look at this one first. Okay, and yes, these problems are longer because your whole purpose in doing these problems is to simplify them to make them shorter. And the way we do that is by distributing and combining like terms. So once again, you must distribute first. 6 times 4m is going to give you 24m. 6 times 7k is going to give you 42k. And then write all the other stuff left in the problem behind it. Okay, now you're ready to combine like terms and keep them alphabetical. Right? Since k comes first, there's nobody who goes with the 42k, so in your answer, 42k is at the beginning. Right? Then you go to your m's, because there's two sets of them, so we can combine them together. 24m minus 16m is going to give you a plus 8m. And then you see the plus 14, which is a constant. Nobody goes with him, so plus 14 goes in the back. So there's the official answer, and that is as simplified as you can get for that problem. Right? Still doesn't look too short, but it's as short as it will get. All right, then the third one, like I mentioned, was a geometry problem. Right? You are going to see shapes popping up in this class because it's getting you ready from where you're going to go next year. Right? But you have on the outside algebraic expressions, and the directions are going to say to find the perimeter. Well, when you find the perimeter of any shape, you're adding up all the outsides, which is essentially combining like terms. Right? There is no distributing in this one because we don't have any parentheses. So if I take and walk around the outside of this triangle, I have 3x plus 1 plus 2x minus 5 plus 6x. You've now created an algebraic expression that we can simplify. Okay, again, go for your like terms. Take all the x's first, 3x plus 2x plus 6x. So that's 11x. And you'll notice that there's two constants, so you have to get those separately too. There's a plus 1 and a minus 5. So positive 1 minus 5 is going to be minus 4. So the simplified perimeter for this problem is 11x minus 4. Okay, so we'll do a lot more practicing with this in class because this is a foundation for everything that we do in algebra, and you will need to constantly be building on this throughout the entire year.